Hi and welcome to today's video. Today we will be looking at how to determine the x and y components of a vector. Now, the steps to follow are: the first thing we do is draw the given vector on an xy plane. After that, we draw a horizontal line and a vertical line. The last step is to use SOHCAHTOA to get the components. Now let's see what this means. Our question reads, determine the x and y components of a displacement whose magnitude is 5.5 meters at an angle 240 degrees from the x-axis. Step 1. We draw the given vector on an xy plane. So that's our vertical axis and the horizontal axis. Now, how do we draw this vector? Well, we've been given the angle, which is 240 degrees from the x-axis. So if we start from the x-axis, we go around, this is 180. 180 plus 60, that's somewhere here. This is going to land us our vector. So our vector is somewhere here. Next step is draw a horizontal and vertical line. The horizontal line is our x component and the vertical line is the y component. The vertical line has to be parallel to the y-axis, the horizontal line parallel to the x-axis. Now let's give these names. Let's call our vector as d, so that we call the y component as dy, then we call the x component as dx. Now, is it true that we can draw dy on this other side so that we make a right angled triangle? Is this and this the same thing? The answer is yes. If we can draw dy on this side, we get sort of a triangle, which is like this. We get this is dx, this is dy, and this other side we get d. Now that we have it like this, this is now a triangle with our angle here as theta. To determine the xy components, it says we now have to use SOHCAHTOA. So the first part of SOHCAHTOA, so, is sine theta is equal to opposite over hypotenuse. Now what's the opposite side here? If this is our theta, the opposite side is dy. Sine theta is equal to, and the hypotenuse is simply d. Let's make dy the subject because it's the one we're looking for. So dy, to get dy, we cross multiply so that we have dy is equal to d times sine theta. And finally, the value of d is 5.5 sine our theta. We have to use 240 degrees as theta. Now let me explain why. The triangle which is formed here looks like the angle here is supposed to be theta, is supposed to be 60 degrees. However, sine 60 and sine 240 give us the same value, which is roughly around 0.866. Sine 240, however, gives us a negative 0.8, so on and so forth. Now, the reason we have to use 240 is even though they give us the same value, the quadrants in which the vector lies is different. So when we use 240, that gives us a more accurate value. Although 60 works in the case of the magnitude, but since vectors have both magnitude and direction, the negative sign is important. So we have to keep the angle as 240. So let's calculate dy. 5.5 sine 40. Now make sure your calculator is in degrees here. Irabipa calculator in radian. Yeah. So this value is negative 4.76 meters, and that is our dy. Next, we want to get our dx. We have to go back to SOHCAHTOA. We'll use cos theta. So cos theta is equal to adjacent over hypotenuse. The adjacent side to this is dx and the hypotenuse is d. So cos theta is equal to dx over d. Making dx the subject, we say this is over 1. We cross multiply. This gives us dx is equal to d cos theta. This then gives us 5.5 cos 240. This gives us negative 2.75 meters. So this is our x component and this is our y component.